Moving on now to the room dimensions worksheet. So first of all, you might be wondering where the building plan is. In the previous version, we allowed both options. It's just one input form now, the room dimensions. However, there is a way to do a block load, probably faster and also more accurate because it at least separates loads per floor if we do a block load with the room dimensions page. So we're going to have a video on that as well. But right now we're just going to show this, this room dimensions worksheet and how it goes. First time you open it, you're going to see these comment bubbles. I recommend reading through these. This is about decimal places, reminding you that even though you might see a decimal cut off, right? I typed in 0.222 and it just says 3.2. Even though it's cut off, you can see the whole value is still stored. So don't worry that it's rounding. It's not rounding, it's just rounding to display. This is about the recalculate button. Read through this tooltip. So this whole section here is the room input form. This is all the information for one room. Below that, we have tools for combining windows, for estimating radiant back losses, that's a new tool, and also for calculating a net thermal resistance if you have different wall types. So in this room dimension form, so I'm in the form now, I can enter in this information. You'll notice up at the top here, this header is not part of the form. This is a locked header. This is your navigation toolbar, so you can go to different rooms with these arrows. You can also jump to any room quickly. If I want to go to room 19, I don't have to click the arrow 19 times. I can just type 19 and click go. Now I obviously haven't defined any rooms, so they're all just blank right now. I'm going to go back to room 1. If I want to clear the room, click this button. If I want to view a list of all the rooms that I've defined, I just need to click this button. It's going to take us to a new worksheet, defined rooms. And if I had defined any rooms, they would be listed in table format here. This is just a quick way for you to view the rooms that have been properly defined. I can click back to room, or I can just click on this worksheet again. So we also have the room. I can go view my room IDs as well. So this shows us all the construction types that we have correctly defined. Right, so if I'm over here in the room dimensions page, oh, I did it again. So I guess we do recommend clicking the button to go back. So yeah, when you click these buttons, we'll update this glitch in the next one, but don't navigate back by pressing this because you're going to get this error. Instead, just click the button to go back to room. So let's say I want to refer to walls, but I have a bunch of different wall types defined. That's what I can use this button here for, is to view my IDs. Oh, right, okay. Wall type 3 was that wall 1A with 17.72. So I know that I need to refer to wall type 3, and that's where I would type it in. So that's what these buttons are for. It's just a quick kind of glancing tools for you. We also need to select the direction that the top of plans are facing. That's why you have this yellow warning here, because we haven't selected our direction yet. It reminds you that if you do change direction, you should click the recalculate button. The room inputs are very similar to before. Again, I'm not going to go through all these red hover notes. I recommend going through them. If you're very familiar and comfortable with the previous version, I imagine this version, you'll pick it up really quickly. If not, I strongly recommend reading all these hover notes and be very thorough, especially in this table here. This is where you define the walls and the windows and the doors, and down here is where you define the ceilings and the floors. Each column has a heading that you can hover over to get more information on that input, right? So just for example, I see this, SHI, what is that? Or what is this arrow? So I'm going to hover over this. This is the direction facing. Each arrow corresponds to a direction of the building floor plans, right? So now we're no longer typing in the direction. We actually just have the top direction, top right, diagonal, right, bottom right. So these are locked, and what you select as your top of plan is going to affect what direction these are. So I've selected north as the top of my plan, so you can see this first row is all north. The direction is labeled here. And if I were to change this to east, now the top is east. It also shows you a compass layout of what your drawings should look like. So we enter in the wall, the header. Header is now separated from wall. So in the previous version, we had the walls and headers defined together, but now they're separate. So if I have a wall area, let's say it's wall 1, and the length of the wall is 10 feet. You know what, here, I should make a couple inputs over here so we can see this. So let's say I have a basement that's 1,000 square feet. The total wall height is 4. The foundation wall height, meaning the concrete, comes up 4 feet. I've got an above grade floor and the total wall height is 9, so it's a 2-floor building. Header area is going to be the same. We include headers with the floor above now. That's also a change from the software below. You can still do it that way if you like, but this is the new way that we're recommending. We believe it's more accurate for loads and it helps on the user inputs as well. So I've got a basement. Oh, sorry, this is actually with the basement now. So I've got 1,000 feet of header area in the basement as well. And header height is going to be 1 foot. Let's say it's 2x10s with a little bit of flooring and whatever else. Okay, header area, none, header height. Okay, so there we go. So now when we come over here, oh, I also have to define the number of floors, 2. I think that should do it. Yes. So now you can see when I'm specifying the floor level, so room, let's say it's the TV room in the basement, and floor level is 300 square feet, I can specify B for basement or 2 if it's on floor 2. Floor level is the term we're using now. It's not stories. Floor level is total floors of the building. So now that I've entered in, let's say B for the basement, if I have 10 feet of exposed length on the top wall, it automatically calculates the area as 40. Well, how did it do that? Because remember I specified the total wall height as 8. Here, let's actually say the total wall height is 9 and the foundation wall height is 4. Well, what that implies is that there's a 5-foot framed wall or a pony wall built on top of this 4-foot foundation wall. And it tells me that height down here. And that's how this area is calculated automatically. If I ever want to specify a custom area, I can do that beside it here. And that will override whatever this is. I also have a header. As soon as I type in the ID, it's going to show me the automatic area calculation of the header. How did it get that? Well, 10 feet of exposed length and 1 foot is my header height. Again, if I want a custom area, I just enter it here. Okay, windows and doors are the exact same as before in the previous version. Again, if you want to know more about this, you can just hover over every heading here. This goes in detail on each input type. If you have more, so right now we allow for a window and a door with a window in it. And we also allow for a whole nother window input. So this encompasses most situations. You can also enter in custom U values and solar heat gain coefficient values for the window. We added this in because we know it's common for window schedules to have slightly different properties for different windows depending on their size and style, even though they might all be rated, U value 1.4, solar heat gain 0.28. You might get slight variations. So we allow custom inputs for each window. I think that's everything we need to see for windows and doors. Right, so it's important to just remember that this door and window here, this window is going to be in the door. So if I enter in the width of the door as 3 by 8, and then I've got a window in the door, a little 2 by 2 window, it's going to take that area out of the door, assuming that this window is built in the door. So, yeah, you can, let's say you have 3 different windows that can't be, combined in the inputs, all facing the same direction in the same wall. And you could use this as a window input if you wanted to, but it's going to show up as a door heat loss. That's the only thing. Okay, so that was all for the top direction, right? And then we've got all the other 7 directions down here. Ceilings with skylights or doors or hatches in the ceiling, those can all get specified here. And exposed floors can get specified here. If you want to define a radiant floor, this is also where you specify it. You choose your ID. Remember when I type 1 here, what that means is exposed floor ID 1. So that's referring to exposed floor ID number 1. So it's going to be referring to this floor and R value. The area of the floor. If I have a radiant floor, I just enter Y here. And it says to do that in the hover note. I enter in the temperature of the fluid in the floor. So whatever the circulating temperature is of the radiant fluid when I'm in heating season. So maybe it's 45 Celsius. I would type in 45 C. I can also type in a Fahrenheit unit if I want. And I would just type F in here. Okay. If I have foundation elements, I click on this box. I choose my foundation ID, right? So if I have a 1 here, that's referring to foundation ID 1. I type in, it's very rare to have a custom slab area. You should read this hover note. You could probably assume that you would leave this blank for every room in every project you ever do. It's very rare to have a customized slab area. Usually if you have a foundation room, the whole floor of the room is part of the foundation slab. And then you enter in the dimensions here. Oh, so sorry, what I'm saying is just leave this blank if you don't have a custom slab area. So you can assume probably most projects you're going to just leave this blank. Now we enter in the dimensions, the foundation dimensions in this room. So I can choose to enter in either different segments. So sometimes in rooms we have, 3 walls facing different direction. I've got a 5-foot wall facing down. I've got a 12-foot wall facing to the left, and a 13-foot wall facing to the top of the plans. And then I've got different wall heights and everything here. So this is how you can do those inputs. My foundation wall height was, let's say that was buried at 9, and then maybe it's down to 6 here, and then it's just a walkout basement. So it'd be 0 on the top. And then height above soil line, maybe height above soil line, 1, 1, and 0. So you could enter them segment by segment like that, and this does the calculation for you. Or you can just enter in the length of the overall slab edge. So for example, this would be a 30-foot slab edge length. The total wall area, so maybe I know I measured on the plans or something, and I know the total wall area is, 89 square feet, and area above the soil line is 15. I can choose to do my dimension inputs one of these 2 ways. Okay, next up we have the heat losses and heat gains due to ductwork. So anyway, if you have ductwork that's in space that's not conditioned, you specify that here. If you have radiant pipe that's in space not conditioned, this is radiant pipe serving the room, like the distribution piping. If you also want to add in any custom loads, you can do that here. Okay, the window combiner tool, we're going to go into this in more detail for the block loads, because this is how you add multiple windows together in one facing direction. But for now, I'll just show you. You can type in a bunch of different windows. Maybe I've got windows with different properties. Right, and I want to combine all these windows. For example, right, these are a whole bunch of different windows I entered in. This is showing you how you can enter that as one combined window. So you would just type in this value here. Now, you can also use, you can see there's a direction here, right? So it depends on the direction. So I want to make sure it's facing the right direction. Let's say it's facing north. I couldn't fit all of these windows in to the inputs I had here, right? I only had two spaces. I had this space and I had this space. So I couldn't fit all those windows in, so I wanted to combine them. So I typed them all in here. This is my combined window. I could type it in directly if I wanted, or I can just click Save to Room. You'll see what happened is it actually just sent all of these inputs to the room. So we've got custom properties as well as the dimensions. And that was the north-facing direction. More on this in the video on how to do a block load. We also have a radiant back losses tool. This is not a CSA calculation. CSA does not actually discuss radiant back losses. This is an estimate to use for back losses in conditioned space, right? So what that means is you've got a radiant floor in the ceiling of a basement. That radiant floor is meant to heat the room above. However, because it's a hot floor, some of the heat is going to get lost downward to the room below. Obviously, with radiant floors like that, you should have some sort of insulation or reflective material to push those radiant heat, that radiant heat back up to where it belongs, right? What you're trying to do with that floor is heat the room above it. However, you might have some losses that come down, and you can make inputs here to calculate an estimation for that value. You can also calculate the net thermal resistance of multiple assemblies. So again, this is useful for the block load tool. Maybe in a room you've got old wall and new wall. You didn't end up making renovations to some of the walls, so you could type in different R values and different areas here, and then it gives you the total combined down here. Okay, so that is the room dimensions worksheet for doing the room by room inputs. The next video will be showing how to do a block load or an overall building calculation.